Hi, my name's Stewart Lynch, and in this video I'm going to explore two related view modifier methods. The first being the ignoreSafeArea method, and the second the SafeAreaInsets modifier. Both return new views for the ones that they are applied to, just like other view modifiers. And, as usual, there might be one or more tidbits in this video to show you something else you may not be aware of, but might be useful in your projects. If this is something you want to learn, then keep watching. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. I have a starter project for this video, and I encourage you to download it and work along with me, testing out and making adjustments to the code as you go. You learn from doing more than you do from watching. In the end, you'll have a sample project with code that you can refer to in the future. First, let's take a look at IgnoreSafeArea and see what that really means. In the starter project, I have a simple view that displays a red color view on the screen. For the preview provider, I've added 4 different previews so that we can see what the safe areas mean for the 4 different types of devices. What I recommend that you do is to use the Xcode previews to display orientation variants so that you can see the different orientations. The iPhone 14 Pro is the latest design for iPhones, and it has that dynamic island on top. And though we can't see it in this preview, if we were to run this on a device or on a simulator, you'd see the line representing the home bar at the bottom. Both of these areas by default are outside of the safe areas for content display. And when I rotate to landscape mode, we see a third restricted area at the bottom, and that represents the area for the home bar, but there's also a leading edge unsafe area as well. The iPhone 14 has the previous design, which is pretty similar, but instead of the dynamic island, we have the notch. Same safe areas as the iPhone 14 Pro design in both portrait and landscape. The iPhone SE has the original design, this time only safe areas at the top, while in portrait mode. And the iPad, on the other hand, has safe areas at the top and bottom, regardless of orientation. This is important information to know when you're designing for multiple devices and orientations if you wish to alter safe areas for your applications. So let's see what we can do and what effect it has on our designs. Let me embed this color within a navigation stack. Nothing happens until we specify a title or a toolbar item for the navigation bar, because it's not displayed until such things are added. We see that the safe area grows at the top in portrait and is added in landscape mode for all devices. If I embed this root navigation stack view inside a tab bar, the bottom safe area grows to include space for whatever we might have there too on all devices. So let's add a tab bar item to that view, which is the navigation stack, and we'll just make it a label with the system image of a 1.circle.fill. Well, we can apply a modifier to our color view that's expanding to fill the entire safe area and tell it to ignore the safe areas. Without any arguments, the ignoreSafeArea will now consume space available to all 4 edges on all 4 devices. The ignoreSafeArea method, however, has 2 arguments. If I option click on the method, we see that there is a region and an edges parameter. The regions is an enum set to all, and I'll get to that a little later. The edges is an efficient set of edges defaulting to all, and that is why we are seeing the color view now expanded to the edges of our device on all sides. Leaving the regions out for now, let's specify a single edge to ignore, like this one, and here you see all 7 of our choices. As I make different choices, we can see the effect in the preview. If you want to adjust to just keep the area reserved for the notch or dynamic island, as well as for the home bar and tab bar, but spread to the leading and trailing edges, we can simply specify a IgnoreSafeArea for the horizontal edges. If, however, you want to let the content flow into the tab bar area to cover that as well, you can do that by specifying a set of edges and include the bottom. Let's just go back to horizontal for now. Now, it's not likely that you'll have a color with your only view in your app. So let me embed it in a Z-stack so that I can add some other views in front of it eventually. Placement and the type of container really matters for the IgnoreSafeArea modifier. In our case, we're applying it to the color red that currently is expanding to the two horizontal edges while respecting the top and bottom safe areas. We can add ignoreSafeArea edges bottom modifier to the Z-stack, and then this will tell the Z-stack to make available to the color view all of the space available to the bottom edge, ignoring that safe area. So the color view will accept that and expand to consume that entire space. Let me just comment this out right now. It's not likely that you'll just have that color view on its own. So let's add a text field here. So we'll first need a state property that we can bind to the text field. So we'll just call it text entry and it'll be an empty string. Now I can add that text field to our view. And then I'll apply some modifiers like a rounded border style and add some padding. To really get an understanding of how this works, I'm going to run this in the simulator. If I tap into the text field, I'll have to make sure that the keyboard is displayed, so I'll disable any Connect Hardware keyboard from the I/O menu. And when I tap into that field, the keyboard is displayed and the text field moves up. The keyboard overlays the tab view, and we don't see it, but what is happening is that the red color view is only ignoring the horizontal edges. So when the keyboard appears, that bottom safe area actually comes up and reduces the space made available to the root view, which is now reduced so that this means that our Z-stack has less space to offer the color red and the text field. And that text field then moves up to be centered within the available space, which makes sense. If I add a text view as an overlay to the color red, I can set an alignment to bottom, and this will show you what I mean. Let me run the app in the simulator once more and tap into that text field. We'll see that the available safe area has been reduced, and because the content is only ignoring the horizontal safe areas, the Z-stack itself observes this bottom safe area, and the space available to the red color is also reduced, and so when the keyboard appears, everything moves up, and the text view is centered within the space available, as is the norm in the text field as at the bottom. If I uncomment the Z-stack SafeArea modifier and run once more, let's see what happens. This time the Z-stack ignores the safe area, as does the red color view, so the text field does not move and our overlay text field is somewhere still at the bottom of the screen. The behavior of reactions to the keyboard, however, can be controlled. And that's the second parameter for the safe area that we have ignored so far. And this is the regions parameter. If I option click on the IgnoreSafeArea modifier once more, let me drill down on the safe area regions to the documentation. We see that the default region is all, but there is also a container and a keyboard region specifically. Let me return to Xcode. And because that first argument for this function doesn't require a label, we can simply specify a different region from all, which is the default. So let's try container. Well, visually nothing changes. Remember the last time when we didn't specify a region and tapped into the text field didn't move? Now, however, when we do this, we're saying that we should not ignore the region occupied by the keyboard. So this time, when we tap on the text field, the container does shrink to respect the region occupied by the keyboard, and the text view moves up to be centered, and the text view overlay is at the bottom. If we return now to the code and change this to ignore the keyboard only, then we see that our safe area is immediately displayed in our previews. If we run this in the simulator though, because the ZStack is ignoring the keyboard safe area region when we enter the text field, it doesn't move. So there are 2 points to make note of here when you're developing your apps. The first is to know how to extend your content into different safe areas of your devices, and the second, which is often ignored by new developers, is to pay attention to text entry when your views allow it. If you have enabled safe areas in different views, you must test on the simulator or device and make sure that you bring up the keyboard to ensure that you're able to continue to enter text, because if your text views are lower or hidden by the keyboard, then you're going to have some unhappy users. Now, before I introduce you to SafeAreaInsets and the power of SafeAreaInsets that were added in iOS 15, let me first take a look at how a scroll view or list deals with safe areas, because this is something that you will likely encounter. In this new view, I've created an array of strings that I call to-dos, and it's simply the word to do, and to that I append the index that I create from an array of 50 of these. Now, do you notice something strange here? It would appear that the scroll view doesn't obey the vertical safe areas. If I display the orientation variance for this device, it appears that the list or scroll view only obeys the horizontal safe areas. Now, if I add a list row background color of, say, red, with an opacity of 0.4, we'll actually see that the list does, in fact, obey those safe areas. It's just that the safe areas scroll with it. If we scroll all the way up, the safe area at the bottom stretches but always bounces back to the default size with our list content above it. Similarly, if we pull down, the safe area is there and it stretches with the pull of the scroll view but always bounces to the default size again with our list below it. Now, if we choose to apply an ignoreSafeArea to the list view, we'll see the content, while not scrolling to the edges, fills the entire view. Let's add a navigation stack here, and along with the title, and I'm going to change the ignoreSafeArea to only ignore the bottom. Well, what would this look like if we are also embedded within a tab view? So I'm just going to return to the previous view where I have the tab view, and I'm going to add another one, which is just going to be this insets view. And then I can create another tab bar item, and I'll just use the same label but change it to second and use the image 2.circle.fill. Well, the issue I have now, though, is that even though that the tab bar is being displayed, that bottom row gets cut off. So we can solve that problem by going back to the Insets view and remove that ignoreSafeArea altogether. This is especially important if you have a tab bar. And also, let's remove the list row background color. Well, in iOS 16, we were introduced to SafeAreaInsets, and this allows us to add views to the safe areas. Well, we can apply SafeAreaInsets modifier to our view, and it has 2 required arguments. The first is that edge, which we want to apply. So we're going to either apply it to the top or the bottom. So let's start with top. And the second argument is just a content, which is a view. So we're just going to create a button that will have a label of OK. I'll just leave the action empty for now, but I'm going to change the button style to be a bordered prominent button style. Notice that the button extends the height of the top safe area now, and our scroll view settles below it when we are scrolled to the top. If I scroll up, however, it shows that the scroll view goes behind this extended button. Well, we can fix this by embedding the button in a container and setting a frame on it that will extend to fill the width and then apply a background. So first we'll embed the button in an H-stack, as I'm going to be adding something else here in a minute. Then I'll apply some padding to the H-stack. I'll set the frame to be the max width being infinity so that it'll extend the entire width of our view. And then, as I said, we can apply a background to that entire H-stack. And if I apply a background with no argument, it'll apply the default background style. Scrolling now, we see that the list appears to go behind the new top safe area. But when it's at rest and we're scrolled to the top, it settles below that area. Now, if you want to increase the spacing between the new safe area and the resting top of the scroll area, then we can add some spacing, like 40. Well, we could also add an alignment before the spacing. So, for example, we could use trailing. Well, this doesn't appear to do anything because we have that frame that extends that H-stack to the entire width of our view. So let's just comment that out now. And it now appears that this view is floating to the right, but sticks to the top of our navigation bar as we scroll, but remaining content is on the left and it's visible. So you might think of some useful techniques here for floating buttons of some sort. I'm going to do something else though. I'm going to add a text view here that will allow me to update my to-do list with more content. So let me revert back to the full max width frame and no spacing or alignment. So for text view, I'll need a state property for our new to-do, and I'm going to initialize it as an empty string. Then within the H-stack in our SafeAreaInset, I'll add a text view that's bound to that property. And then I can apply a rounded border text field style. Well, for the action, then we can insert that new to-do as the first element of our array so that it'll appear at the top of our list, which is that index 0. And then I'll reset the new to-do state property back to an empty string. Well, let me test this in the simulator so that I can see the effect of presenting a keyboard. When we scroll, we see that that SafeAreaInset is fixed at the top, allowing us to enter a new to-do. And we see it gets inserted as the first item in the array, so therefore at the top of the list. If I scroll down and enter, I can still make another entry, but I don't see it unless I scroll back to the top. So I consider I have two issues here. First, I don't like the fact that the entry is at the top of the screen. It would be better if I could in fact just tap into that entry field with my thumbs, and that would be better if it was near the bottom of the screen. And also, whenever I enter a new item, I'd like it to scroll to the top to display that new entry. So let's fix the first issue first, because it's really easy. I can simply change the edges to bottom instead of top. To fix the second issue, we'll use a ScrollViewReader. So we can embed our entire list and SafeAreaInsets into a ScrollViewReader, which provides us with a ScrollView proxy that we can use in our code. It acts very similar to how a geometry reader works. Well, we'll need to provide a unique identifier for each of our rows. So in order to do this, I'm going to switch the list from iterating through the to-dos to iterating through its indices. And this will provide me with a unique int, and will also allow us now to enter two identical to-dos and not have any issue with the display. Now that we have this, I'm going to have to change our text view so that it's displaying the to-dos array at that index. And now for the ScrollViewReader to work, we need to specify a unique ID for the row, and for that I can simply use that same index. And then there's one last step, and that's to scroll to index 0 when we've added a new entry. And why don't we do that within an animation block? Let's test this on the simulator. Notice when I tap the entry field, the inset goes along with the rise of the keyboard so that it's still visible. And when I enter a new to-do, it gets inserted at the top. If I continue to add more to-dos, even if I scroll down in the list so that the top is not visible, after entry, the scroll view scrolls back to the top with nice animation. Now there's just one more thing I want to add here, and it's just me being picky. As it is now, I can enter a lot of empty to-dos. So I can quickly fix this by returning to our button and make it disabled if a new to-do is empty. Now when I test this out, I see that that button's disabled until I enter some text in the new to-do text field. Well, I hope you've learned something new in this video that you can use in your projects. If you enjoyed the video, please give it a thumbs up and leave me a comment. This helps drive more viewers to my channel. And if you want to get notified of new videos, be sure you subscribe to my channel and enable notifications. Thanks for watching.